Hi, welcome to Algebra 2 Common Core. Today in lesson number 3, we're going to calculate probabilities using two different methods, a two-way table and a Venn diagram. Sometimes a two-way table is also called a bivariate table. Using both of these methods, we will be able to see how events or sets can combine by looking at unions or overlap by looking at their intersections. So let's start with example number 1. A small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of four events. So for our options for gender, we can either have a male or a female. And for their plans for college, they can either be going to college or not going to college. So you can clearly see that there are four different boxes in our table that specify those numbers. Now when I look at my table, I've also set it up so that the males are all in this column. So when I add together the males going to college and not going to college, I get the total number of males. Likewise, the female students are in this column, so the ones going to college plus the ones not going to college give me the total number of females. I can also read my table horizontally, so I can look at the students who are going to college. If 16 males and 13 females plan on going to college, that's a total of 29 students who plan to go to college. In the second line, the not going to college students, there are 14 males, 9 females, so 23 students altogether not planning on going to college. You'll notice that this number in the bottom corner is the total of all of the students that we have surveyed. So, reading this table carefully, we can answer the following questions. So, give the values for each of the following. N stands for the number. So, the number of males specified in our chart is going to be the total number of males. So, looking in my male column, I see that there are 30 males. Number of females, look in the female column, and there are a total of 22 females. Number of people planning on going to college, so that means that I'm looking at this row right here. And again, the total for that row is going to be 29. And the number of students not going to college would be the total of this row, and I see that that's going to be 23. Now, when I'm looking at an and in the next example, I've got the number of students who are male and planning to go to college. So you'll notice that in our box, in our table, the males were here, the going to college were here, so where they come together would be the males going to college. There must be 16 of them. If I look for the females and the college students, here are all the females, but here are specifically the ones going to college. So I see that 13 would be the number of females who are also planning on going to college. Now, when I look at the last example in this section, I notice that there's an or. When I see an or, that means that I want to take into account the number of females right here, or the number of students going to college right here. But be careful, I don't want to count this group of females twice in my totals. So I can break this down into the number of females or college would be equal to the number of females plus the number going to college, but then I've got to subtract out the number that are females and going to college because I've already counted each of those groups. So the number of females or college would be equal to the number of females, which I see as 22, plus the number going to college, 29, minus the number of students that are females and going to college, because I've already counted them. So let's subtract 13, and when I do that, I see that this total is giving me 38. Now, using each of those numbers, because the numbers just represent how many are in each category, we can then calculate probabilities for each of these. So if I want to know what is the probability that a person picked at random would be a female who is going to college, I want to say this is the probability of female and college. So that means that I want the number of people that are both female and going to college. But then I'm going to divide it by the number of people in the complete set. So in this case, I see that F and C from above is 13, divided by the total number in the sample space, the total number surveyed, 52. So when I divide that, I can reduce it to 1/4 or 25%. For part C, what is the probability that a person picked at random would be a female or someone going to college? So you'll see in this very last part that we calculated right here, we got 38 of those students out of 52 altogether. So I can divide that or reduce it, and I'm getting approximately 0.73 for that probability. In our next example, number 2, we're going to practice filling in both a Venn diagram and a two-way table. So example 2 says, suppose that 62% of the books are works of fiction. 47% are available as ebooks, and 14% are available as ebooks but not works of fiction. So a book will be selected at random, and let's start by filling in my Venn diagram. So I probably would start with the number that are available as ebooks but not as works of fiction. So when I look at this, E stands for ebooks. So here are the ebooks, but the ones that are not works of fiction would be the ones that are just in this set right here. So that tells me that 14% have to go in that category. I'm going to convert 14% to a decimal, so I'm going to say 0.14. Now, because I know that there are 47% available as ebooks, this entire circle has to add together to give me 0.47. But I already know the right-hand side is 0.14, so when I go ahead and do that subtraction, I'm getting a 0.33 for the part that's the intersection. So I'm going to label this part right here 0.33. Now, I also know that 62% are works of fiction. So that means that this whole circle on the left, the F circle, is 0.62, but the intersection was 0.33. So when I subtract that, I'm getting that there is 29%, or 0.29, in the part that is works of fiction, but not available as ebooks. Now, to finish off this whole Venn diagram, we're going to need to know how many, or the percent, that falls outside of both of the circles. Remember that our total has to be 1. So I'm going to say 1 minus. But first of all, let's get our total. So the total of books that are available as fiction but not ebooks, plus 0.33 is the ones that are ebooks and fiction, plus 0.14, those are the ones that are ebooks but not fiction. When I add that total together, I see that I'm getting 0.76. So I'm going to start with 1 and I'm going to subtract 0.76 and see that the percentage of books outside of both of the circles would be 0.24. So I'm going to put that down here and say 0.24 are outside the circles. Now, let's see if we can convert this information over to what we call a hypothetical 1000 table. We like to use convenient numbers when we're talking about probabilities or percentages. So one convenient number that we can use is the number 1000. So that's hypothetically, if we surveyed 1,000 or if we looked at 1,000 books, how much of them should turn out to be works of fiction versus ebooks not works of fiction. I'm going to use the percents from my Venn diagram. And I'm going to say, okay, the ones that are available as ebooks that are fiction as well would be the ones that are in the intersection right here. So that's 33%. So basically, I'm just saying 0.33. sorry about that, I need a pen, 0.33 multiplied by the 1,000 books that we're considering, and that gives me 330 books. So in my table, I'm going to say 330 would be the number of books if I had 1,000 books altogether. If I want to look for the number that are available as ebooks, but not as fiction, that means that I want the ones that are over here on just the ebook category. Again, take 0.14, multiply it by 1,000, and that's giving me 140 books. Now I'm in a position where I can go ahead and total these. So when I add those two together, I see that I'm getting a total of 470 books in the category of ebooks. That made sense because remember, we were told that 47% were available as ebooks. And the two-way table allows us to put that total, which makes it a really nice format. Now we can also work ahead and say, okay, if I know that I've got 470 that are available as ebooks, and there are 1,000 ebooks altogether, go ahead and subtract and see that, oh, 530 must be not available as ebooks. Now let's look at the rest of our percents. If I want to say the number of books that are fiction, I could look at the ones that are not available as ebooks. So that would be this 29% over here. 29% of 1,000, 290. Add those two together and that's giving me 620. And again, that answer makes sense because it says 62% of the books are works of fiction. I'm going to go ahead and subtract and see my other numbers here. So 530 minus 290 tells me that this box must be 240. And again, that makes sense because that's the number of books that are not fiction and also not available as ebooks. That was my 0.24 outside of the whole box. Finish it off by adding together these two columns, so I've got 380. But notice that also when I add these two together, I am getting 1,000. So every row has to add together, every column has to add together, and my totals in both directions have to add to 1,000. So whether I use my Venn diagram or my two-way table, now it's going to be pretty easy to calculate some probabilities. So the first one says, let's find the probability that a book is a work of fiction and available as an ebook. So that's going to be the probability of F and E. So look carefully in your table. F is all of these, E is all of these. So I want the number where they cross each other, 330. And we're going to say, okay, 330 hypothetically out of the possible 1,000 books that I have. And again, I can convert that over to a decimal as well, 0.33. And I did see that on my Venn diagram right there. For the last part, let's calculate the probability that the book is neither a work of fiction nor available as an ebook. That's going to be the not fiction together with the not available as ebook. So that's 240 out of 1,000, which is 0.24. And again, looking at my Venn diagram, that's the decimal that I found outside of both of the circles. Now when I have a problem like this to solve, it really doesn't matter whether I use a Venn diagram or the two-way table. So again, in this situation it says, let's draw our Venn diagram first. So when a fish is selected at random from the tank, the probability that it has a green tail is 0.64. The probability that it has red fins is 0.25, and the probability that it has both a green tail and red fins is 0.19. Whenever I have that both number, that makes it really easy to start right there because that, of course, is my intersection. So I'm going to put the 0.19 in there. Now the red fins would be the red circle here, so that total has to be 0.25. But I'm going to subtract 0.19 and get 0.06 for the rest of the circle for the red fins. I also know that I've got green tails 64% of the time. So I can say 0.64 and subtract the 0.19, and that's going to give me 45% or 0.45 in the left side of the circle specifying green. Finish it off by adding your numbers all together and subtracting from 1. So I've got 0.45 plus 0.19 plus 0.06. That total is 0.7. So 1 minus 0.7 tells me that outside the two circles is going to be 0.3 or 0.30. And again, when I add together all four numbers, I should get a total of 100%. Now I can use this information to fill in my two-way table, and again I'm thinking of this as a hypothetical 1000 table. If I'm told something different, I'll use different numbers. This one we want to be the total of 1000 again. I want you to pause the video for a minute, fill in this table, and try to calculate the two probabilities below, or three probabilities below, and then come back and check your work with mine. Hi, check your total values with mine in the table, and then check the probabilities below. In example number 4, we're going to look at the information given to us when high school students were surveyed about whether they owned a PlayStation or a Wii. This time we see that we surveyed 100 students. So when I'm going to fill out the table, and this time I'm going to do the table first and then the Venn diagram, I want the total of all of the students to be 100 instead of that hypothetical 1000. Again, we're just picking a number that's convenient to use. This one happened to have a survey of 100 students. Now, what do we have to have? We have to have one direction be Wii, the other direction be PlayStation. So of course this will be the not Wii, and this will be the not PlayStation. So I'm going to fill out the table kind of by looking at my information. So 70 owned Wii, so that means that the total of all the Wii would be 70. Therefore I know that there must have been 30 that didn't own Wii. 23 don't own PlayStation, so that tells me that this row right here has to be 23. 9 didn't own either one, so 9 is going to go right here. Now we can work backwards and kind of systematically to see that this must be a 21 to add to 30. And then when I go horizontally here, I'm going to get a 14 here. And subtracting 14 from 70, this must be 56. Adding together all the PlayStations would be 77. And you'll notice that this has to total 100 and that has to total 100. Now, just for practice, let's also put this information into our Venn diagram. So in the Venn diagram, I see that neither is going to be 9. I see that the Wii without the PlayStation is going to be 14. I see the Wii and the PlayStation is going to be 56. And I see that the PlayStation without the Wii is going to be 21. Now again, if I add together all of those numbers, I should get a total of 100. And I also see those numbers in my two-way table. So now we can figure out our probabilities either by looking at the table or by looking at the Venn diagram. So the probability of having a PlayStation, altogether there are 77 students who have a PlayStation out of the total 100 students altogether. Probability of no Wii, there are 30 students that do not have Wii out of 100 students altogether. And again, all of these could be converted over to decimals. Now, the probability of PlayStation or no Wii means that I've got to look at this row, I've got to look at this column, but I can't count this one twice. So the numbers that I'm going to be adding together here, the probability of PlayStation would be 77. The number who do not have Wii would be 30. But then I'm going to subtract the ones that have PlayStation and not Wii because I've already counted them twice in my calculation. all over 100. So that's giving me a total of 86 out of 100. For the next row, I've got the probability of PlayStation and Wii. So PlayStation and Wii would be this box right up here. So I see that that's going to be 56 out of 100. The probability of Wii and no PlayStation, that's 14 out of 100. And finish it off with the probability of neither. My neither box is 9 out of 100. So we've gotten a lot of practice in working with two-way tables and Venn diagrams and then using them to calculate probabilities today. We'll work some more in class. Thanks for joining me tonight and have a great night. See you next time. Bye-bye.